With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given that in certain gravity-free space, the piston of injection is being pushed so that water jet comes out with a velocity v. Now the area of the piston is much greater than the orifice, and we need to find the expression for force, power, time for emptying, and also for the work done. So let's say this is our situation. Let's say this is our cylinder, and to it there is a piston which has been attached. Okay, this is our piston. Now at this end, so here we are applying a force. Let's say the force which is applied here is F, and the cross-sectional area here is capital A. Now there is a orifice at this end through which water would be discharged from this end. Okay, and this has been given as to be this velocity is given as to be v. So clearly we can say that, for example, if this is moving with a velocity of v1, and let's say this is here the water is coming at a velocity v, the cross-sectional area here is A, so we can say that flow rate would be constant. So we can say that capital A v1, this would be equals to A into v. So flow rate is defined as cross-sectional area multiplied by the velocity. Let's say this is our equation 1. Now also we can apply the Bernoulli equation at this and this location. So we can say that at this location, we can say that this is our first location, this is our second location. So the pressure P1 plus half rho V1 square. So it is at the same horizontal level. So we are not using the rho GH terms. Okay, potential head. Now here it is open to atmosphere. So we can say that atmospheric pressure, if we treat P1 as to be the gauge pressure, so corresponding to this atmospheric pressure would be equals to 0 plus 1 divided by 2 rho this V square. Velocity here is V. Now pressure we can write in terms of this force per unit area. So F divided by A. Now we can say that if capital A is very, very small, here it is given that area of the piston is much greater. If capital A value is very, very greater, so we can say that our V would be equals to, V1 would be equals to A by capital A times V. Now if A is very, very larger, then we can say that V1 would be very, very smaller as compared to our velocity V. So we can neglect this term. Okay, we can treat that V1 is equals to 0. So the force would be equals to rho V square divided by 2. So this correspond to our A option. Then we can say that our force would be proportional to V square. That means our A option is the correct option. Now the B option is power. Regarding the power, so power is what in the B option? Power is basically force and into the velocity. So velocity would be we can say that V1. So we have written V dash, but it would be V1. Okay, into V1 because force is applied at V1. Now, but we know that V1 would be equals to what we can just see from the continuity equation itself. So we can just write force as to be K into V square. Okay, from our A option, and V1 would be from this expression A into V divided by capital A. So from here we can say that P would be proportional to, directly proportional to V cube. So B option is also correct. Now what is the time for emptying? So in the C option, time for emptying. So we can say that A1 V1, which is the flow rate at the section where we at the section of the piston, it would be equals to A into V at the orifice. And what is this volume flow rate? It is the volume per unit time. So we can say that time would be equals to what? Time would be equals to volume divided by A into V. So clearly the time which is emptying for the total volume, if you put the total volume, it would be the time for the emptying. So clearly from this expression, we can say that T is inversely proportional to V, or we can say that it is directly proportional to V to the power minus 1. So that means our C option is also correct. Now in the D option, it is the total work done. Now we can say that total work done would be equals to change in kinetic energy. Now change in kinetic energy would be equals to what? It would be 1 divided by 2 mv square. Now mass would be constant. We know that it is a steady flow rate. So mass flowing would be constant. So we can say that this kinetic energy would be directly proportional to V square. That means we can say that D option is also correct. So all of the options are correct. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.